equals 5 times radical 2, and then 2a equals radical 2x, or square root, right? So I want to make this so that I have a on both sides. So what I'm going to do is see this being multiplied by 2. If I multiply this one by 2, then these two will be equal. Okay? That means that this will be equal to this. So I'm going to go ahead and do that. So I have 10 radical 2 is going to equal, because I multiplied this by 2, it now equals the square root of 2x. Now this, you guys should know how to do, right? How do I get rid of radical 2, the square root? I'm going to multiply or raise it to the power of 2. Because the power of 2 cancels out that square root. And I just had, oh, this one I have a number in front. So I have to multiply, or not multiply. I have to take that 10 and I do multiply the exponents, right? So I get 10 squared. Those cancel out, the square root and the 2. So I get 2 equals, this is all underneath the radical, so it's just 2x. Do you follow me, or I confuse it too much? Okay. 10 squared is 100 times 2 equals 2x. I want to get rid of the coefficient 2, so I'm going to divide by 2 both sides. So x equals 100. Now, when I go to put this in gridded response, I'm going to go ahead and put my 100 in there. That's not what they're going to grade. They're going to, just like, remember you put your names in and we filled out that whole thing. You have to bubble the 1, the 0, and the other 0. Because this is your score. That's what they're going to read for your answer. They're not going to read the 100. Um, and I'm going to go ahead and use this one to show you how to bubble in a fraction. Because I'm sure one of the answers are going to be a fraction. So give me a fraction. Give me a little bit harder one. How about um, how about 3/16? Okay. Now, how many symbols do I have to bubble here? I have the 3, the divide symbol, and then the 6. So that's 4. 4 bubbles you better have for this. Otherwise, you'll get it wrong. So you have the 3, the division, which is that slash right there, right? And then the 1, and then the 6. So then I would have to bubble the 3, bubble the slash, bubble the 1, and then the 6. Okay. It even has decimal points here too. If you get a decimal answer for one of them, you'll have to bubble the decimal point. Okay. Let's do number this one up here. I'm going to zoom in a little bit, see if it doesn't make it better. No, in. Not a whole lot better, does it? Okay, so I have a to the 2/3. And again, this is going to be that whole section that you guys missed in Algebra 1 and We didn't do it in Algebra 2. Rational exponents. Rational exponent in exponential form is this fraction represents the exponent divided by the root. Okay. So if I was to convert this to radical form, because remember, radicals undo exponents, exponents undo radicals, right? If I were to put this in radical form, I would need my radical, right? I'd need my base A, right? What's going to be the exponent of the base here? The 2 or the 3? 2, because that's the exponent. It's the exponent of the base, and the 3 is going to be my root. So my 3 goes into that inside the roots, the radical sign. Okay? Not too hard. So hopefully they'll make an easy question like that for us on the test. And that is D. So you have exponential form, exponent form, and radical form. Okay? But it gets harder. Let's look at this bottom one here, right? My equation here is A to the B over 4 equals 16. And they want to know the possible value of B. So we have to solve for B, right? Okay, so the first thing we have to do is we know that it's root 4, right? This is going to be A to the B with the fourth root. So I need to find the fourth root of 16. Oh, you can't see it? So and again, this is a no calculator thing, right? So the fourth root of 16, which isn't that bad. You should be realize that 16 is a multiple of 2 times itself 4 times, right? It's 2 to the 4th. 2 times 2 is 4 times 2 is 8 times 2, 16. So 16 equals 2 to the 4th. So now we know the A is what? What's A equal? The base here equals 2, right? Which means B over 4 is going to equal what? If A equals 2, yeah, that 4. So now all I have to do is solve for B. How do I get rid of 4 denominator? Multiply both sides by 4 over 1. These cancel. I get B by itself. So what does B equal? 4 times 4 over 1. 16. Isn't that peachy? So hopefully that they'll make, they're going to have at least one of these on the test. Hopefully they'll make it this easy, but I got a feeling they're going to make it this easy. Yeah, unfortunately. Let's do a couple more of these examples. There is a lot of geometry on the test too. Right, because it was during that remote year, which wasn't the best learning year we had in education, right? In fact, it was pretty stinko. All right, let's do number 9. I think I got some geometry sheets, but I think they're tomorrow. If not, I'll find some. Okay. We have this one is the square root of x plus the square root of 9 equals the square root of 64. And you're supposed to solve for x. Now, this is a no calculator test, so chances are they're going to give you perfect squares, right? So assume that 9 and 64 are perfect squares, which they are. What is the square root of 9? 8, right? Square root of 64 is 8. Now solve for x. Going to subtract 3 from both sides. So the square root of x equals 5. And again, how do we get rid of the square root? Raise it to the power of 2. Gets rid of that square root. 25. Again, if it's gridded response, you can't, right? How are you going to guess it? By the way, how many ways can you have? We just did this, right? You got 4 slots here, digits, right? How many ways can you? How many numbers can I put in the first slot? 10 ways, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 10 choices here. You have 10 choices in this slot, and 10 choices in that slot, and 10 choices in that slot. So there is, let's see, 1, 1, 2, 3, 4 zeros. You have 10,000 choices what to put in those 4 slots, not the A, B, C, or D. Yeah, we're actually doing some probability there, right? So you have 10,000 possibility ways to choose. So on the gridded response, you really can't guess. There's nothing there to guess. It's too much stuff. Let's do one more radical, huh? I have the equation here. A to the negative 1/2 equals x. It wants this solve for a. What is a in terms of x? So they want it solve for a, right? How am I going to get rid of a negative 1/2 exponent? How do we get rid of fractions? Multiplied by the reciprocal, so negative 2 over 1. Now remember, this is an exponent though. Cancel this out, right? I get my a to the first, or just a. But here I get x to the negative 2. You're probably looking for the answer and say, hey, it's not on here. How do we get rid of negative exponents? It's been a long time. We did it at the beginning of the year. Okay. Put it over 1. Then we flip the fraction. 1 over x. And then we take that negative 2 and make it a positive 2, right? So it's C. This one's systems. Want to do a little simple math before we do systems? Again, there's, you know, you heard about these SAT prep classes that, they get hundreds of dollars from your parents and they prep you for the SATs. There is content teaching in those prep classes, but those prep classes show you more of strategies than actual content. Okay. Like on this one, I'll show you what I mean. On this one here, where I have absolute value, don't do any computations here. It says uh, is equal to zero for some value of x. So you're going to plug in a number for x, and then one of these is going to equal zero, right? What do we know about absolute values? How do we drop absolute value bars? Anything that comes out of absolute value is positive, right?
Yeah.
So if we have a positive number, what's the only way to get zero?
Negative.
Yeah, you got to subtract. Which one of these is the only one that has subtraction on it? A. It's got a minus one. All the other ones are adding to already a positive number, right? That's the only one that can possibly equal zero. So we didn't, other than knowing the definition of absolute value, we used our logic. Are you tired today, Xander? You look very tired today, Fruit Loops. Besides, you're not even talking. Did you have a little too much bowling fun over the weekend? No. No?
Saturday and then worked Sunday,
Did you work a lot of hours yesterday?
7 almost 8. It was a horrible day, but it was just the factor of what happened at the start, which was horrible.
Uh-uh.
I worked 1 to 9 on Saturday.
Wow, you guys really work sucky hours.
Normally I don't work that
I gotta ask. All right. Again, I got to do one of those strategy things, okay, on this one, and then I'll do it the whole way, okay. So I know that I've got 3 times quantity. It looks like a binomial times a binomial. So I want to start getting rid of parentheses here. So I'm going to do binomial times a binomial first. What am I going to use? FOIL, right? Okay. So first, I've got 2x times 4x. That gives me 8x squared. And I'm right off the bat, I'm noticing, because this is multiple choice, right? Hey, if I distribute the 3 to this, that gives me 24x squared, right?
Yeah. So it's not D or it's not anything.
So now I'm down to 2 choices, right? With just doing that one multiplication, right? Okay, I'm going to do my outside, inside. So I'm going to take my 2x times 1, get a positive 2x. Inside, 1 and 4x is, and then I'm going to, because I know I have to combine all the middle of my FOIL, right? I know I'm going to be combining these. 2x and 4x is what? 6x. If I multiply that by 3, I get
Well, it's gotta be C.
18. It's got to be C. I don't even need to finish it. See how you could like save your times for get through those? But if you did finish it, let's go ahead and finish it, okay? And then the last 1 times 1 is positive 1. And again, the next step would be to combine the inner terms, right? 8x squared plus 6x plus 1. Then I would have to distribute the 3, 24x squared plus 18x plus 3. Then match it up, and sure enough, it's C.
So would number 5 be the same, or I guess the other number 5? Would that be the same way?
This one?
Yeah.
Well, I would go about it the same way.
It's like the same.
Yeah, you got a minus sign in front of parentheses, right? So you're going to have to distribute. So my first term, I have all of these stay the same, right? Or you could do your little shortcut first, right? If you, a strategy,
Just flip all this out.
you know, you got this term. You're going to be adding this term and this term, right?
Yeah.
So that gives us 2x squared y. So guess what? Cancels those right away. Right.
What? How do you do 2x squared y?
Okay, let me write it out. I have x squared y minus 3y squared
Uh-huh.
plus 5x
Okay.
y squared. Minus a minus gives me a plus x squared y. Minus times a plus is a minus 3xy squared. And then a minus minus is a plus 3y squared. See, that was a lot of time, even for me, you know, it was a lot of time. Okay, we combine the x squared y's, and that's how I got 2x squared y. Okay.
So could you just like go down the line and
Yeah, that's what I would do. Okay, and then it looks like these cancel. And now I'm only left with one more term. There's two. I don't even have to check it because I know it's got to be two terms. But we could do it the rest of the way. So I have a plus 5xy squared and a minus xy 3xy squared, which gives me a plus 2xy squared. There used to be a commercial on TV. It was called Evelyn Wood's reading course. Yeah, I don't know. Did you guys ever hear that? Well, it was like instead of reading, all 350 words on a page, you read 10% of them to get, and hopefully you'll get the idea of the paragraph. And there's like some clause of the paragraph and some English thing. And that's they wouldn't read the book; they would just read those clauses. Well, that's the kind of strategies that they're putting here in the test. How about a systems of equations? Let's do a word problem, huh? Number 19 here. At a lunch stand, each hamburger has 50 more calories than each order of fries. So we have hamburgers, but H equals hamburgers. And we're talking about calories in the hamburger. So let's put calories in hamburger. And then we have fries, French fries, right? So I'll say F equals calories in French fries.
That's a very weird question. Why didn't you talk about calories?
It's the end thing, Remember they did the.
No, but like if you chose any food
I know. Okay, so each hamburger has 50 more calories than order of fries. If I wanted to make hamburger calories equal French fried calories, what would I have to do to make these equal? See, there's 50 more in a hamburger. So how would I make them equal? I would have to add 50 to the French fries to make them equal, right? So there's one equation. Then the next one's not so bad. Okay, so I have two hamburgers, so 2H, and three fries is going to equal 1,700 calories. Now, remember how many methods we have for solving systems? We have graphing, substitution, and elimination, right? And we'll finish this one up tomorrow. This would be a good candidate for substitution, right?